And here we are, ladies and gentlemen, back at it again with a little bit of algebra. We're talking about parallel and perpendicular lines. Welcome to the Mastermind channel. This is chapter 4-4. Alright, parallel and perpendicular lines. So here's a line. We can check the slope of this line by finding any point, like here and here. Count up 1, 2, 3 over 2. So the slope of that line is 3 over 2. Up 3 over 2. Here's a second line. We can check the slope of this line. Up 1, 2, 3 over 2. These two lines are parallel. And notice this slope is the same. Up 3 over 2. So parallel lines have identical slopes. Alright, so if we want to use that in writing an equation, we want to write an equation in slope-intercept form. Make sure you read closely what form they want it in. For the line that passes through this point and is parallel to the graph of y equals 2x minus 4. Well, first thing we need to know, remember parallel lines have equal slopes. So there's a slope of 2. It's parallel and there's a slope of 2. And we're going through this point. So there's a couple of ways you can do this. Remember, we want this in slope-intercept form. That's y equals mx plus b. You could take the slope, put it in here, and plug in the point and find the y-intercept. Or you could just go ahead, since we have a point and the slope, we can use point-slope form. Plug that in here, 2, and then plug in the point. Since there's no fractions to deal with, this is an easy way to do that. Distributive property, 2 times x, 2 times 3, gives me 2x plus 6. And then get rid of the 5, because we want it in slope-intercept form, so move that to the other side, and we get y equals 2x plus 11. We'll check back, see the slope is the same, so these are parallel. Now if we want a perpendicular line, okay, how does perpendicular work? Well, this is our original line again. We go up 3 over 2. So maybe a perpendicular line has an opposite slope. Let's check that. If it's opposite, negative 3 over 2, that means we go down 3 over 2. Are these two perpendicular? Perpendicular would mean there's a 90-degree angle here. And this angle definitely looks bigger than this angle. Those are not 90 degrees. So let's try again. Alright, this is 90 degrees. Notice that it is opposite. That means if this is positive, this one's negative. And it's inverse, flipped upside down. So opposite inverse or negative reciprocals. So let's use that to find the equation in slope-intercept form again. Alright, so we want y equals mx plus b through this point, but this time we're talking about perpendicular. Alright, perpendicular to the graph of 2x plus 3y equals 12. This is in standard form. This doesn't show us the slope right away. So what we're going to do with this is put it into slope-intercept form. So if I take standard form, 2x plus 3y equals 12, and solve it for y, then I get slope-intercept form. So here we have 3y. So we need to divide by 3 to get the y by itself. And we get y is equal to negative 2 over 3x plus 4. So the slope is negative 2 over 3. Now remember, the slope of a perpendicular line is opposite inverse, or the negative reciprocal. So the opposite of a negative is a positive. So if this is my slope, I want a positive, and I want to flip that upside down, positive 3 over 2. So that's my new slope, and we go through this point right here. Now we're using a fraction here, so I'll just plug that right into slope-intercept form. That's going to be easier in this case than going to point-slope form. And I can plug 4 and 6 in for x and y. And then I put my x value as a fraction because when we're multiplying, we'll do 3 times -4 and 2 times 1. That gives us -12 over 2 plus b, and that would simplify down to -6. And then we can find our y-intercept by adding 6 to each side. So b is 12, and there we go. There you have it. Y equals 3 over 2x plus 12. And that's about all the fun we can have. So remember to like and subscribe to the Mastermind channel. Ring that bell, become a part of the notification squad.